Hi all, this is Lakshmi working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the topic which I am going to discuss here is all about Hall effect. So we all are familiar with this term Hall effect. So which means that in a conductor or a semiconductor which is carrying electric current. So when you consider a conductor or a semiconductor, when we apply magnetic field perpendicular to the current flow, what happens is a voltage difference is generated, and we call that voltage difference as Hall voltage. So Hall effect means in a current carrying conductor or a semiconductor, when a magnetic field is applied perpendicular to the flow of current, a voltage difference is generated. So we call that voltage as Hall voltage. So this voltage can be indirectly used it can be calibrated to measure various parameters. Hence, this principle, Hall effect, is a fundamental principle which is used in many types of sensors, like magnetic sensors, which is used in wide variety of applications. Hence, this is an important concept here. So now let us discuss about the flow of how this Hall effect process is carried on. So initially, as I told, so when we are considering a conductor or a semiconductor, so a current will be flowing through a conductor or a semiconductor. And when we apply a magnetic field here, which is introduced to the conductor, what happens is charge accumulation takes place. So one side of the conductor, the plate, the charge starts accumulating. And then after when this process continues, after a certain period of time, equilibrium will be reached. So that is the where your electric force and the magnetic force balances. So we call that as equilibrium. And we can measure the Hall voltage, that is the potential difference which is developed across the conductor can be measured, which we call it as Hall voltage. So electric field which is created here is due to the charge accumulation. And when this magnetic field is applied, what happens is the Lorentz force is getting generated. So that will deflect the charge carriers. So once the magnetic field is applied perpendicular to the current flow in a conductor or a semiconductor, this Lorentz force comes into role, which will deflect the charge carriers. So this is the process of the concept Hall effect. So as I told, we could see this how this Lorentz force is deflecting the charge carriers. So it is given by the expression F is equal to Q into V into B. So where Q is the charge of the carrier, that is negative for electrons and positive for holes. And V is the drift velocity of the charge carriers, and B is the magnetic field vector. So this is the Lorentz force equation. So now talking about the advantages of Hall effect sensor. So these sensors are very small in size, and it is also of low cost, and it is highly reliable, very easy to use, and it is a little high sensitive to these certain external parameters, and it is prone to robustness. So these are the certain advantages of Hall effect sensors. So, talking about the disadvantages of this Hall effect is, so firstly is about the mechanical stress. So, what happens is when the magnetic field is applied perpendicular to the conductor, there exists some type of stress which leads to the mechanical vibration. So, this is one disadvantage, and also it is dependent on the temperature, which means that the Hall effect sensor is affected by the environmental temperature. It is sensitive to the environment temperature. And also there exists the non-linearity in this process. And also one of the major disadvantages is the offset voltage. So when the device is in off condition, we could call this non-linearity as there would not be the linear variation with the input and output respectively. And the applications of Hall effect sensors are mainly they are used in medical applications. So there in medical field, it is helpful in monitoring the fluid flow in the medical devices accurately, and in navigation systems in order to detect the magnetic field for Earth's magnetic field for navigation system, and in material characterization, that is the properties of the materials for design optimization can be done with the help of this Hall effect sensors, and magnetic field sensing, which measures the magnetic field for the precise device control. So these are the certain applications of the Hall effect sensors. So today's assessment is the Hall effect is mainly used for measuring magnetic field. And the Hall coefficient depends on the type of charge carriers, whether it is electrons or holes. And the Hall voltage is directly proportional to the current magnetic field, and it is inversely proportional to the charge density. So thank you.